Hi, now I'm going to talk about a question for students of pure math for A level, international A level, for A2, pure math 4. This is C34 October 2019, question 14. The question is regarding or related to the parametric equation. The curve C1 has parametric equations, x equals t squared minus 1, y equals t cubed minus t, where t is a member of R. The line L is the normal to C1 at the point where t is equal to 2. Show that an equation of L is 4x plus 11y minus 78. So for example, if the curve is like this, we don't know exactly how the curve looks like. And here's a tangent at this point. So the perpendicular is the line that's, the normal is the line that's perpendicular on the tangent at this point exactly, at the point where t is equal to 2. So we need first to differentiate, do differentiation. We're going to use the chain rule to get the derivative, dy by dx. And then we're going to replace the value of t in the derivative to get the gradient, then get the negative reciprocal for the derivative to get the gradient for the normal. And then you can replace t in here to get the point. So you're going to have a gradient and point. So you can get the equation easily. So let's start step by step. The first thing, how do I get the derivative? Whenever you are working with a parametric equation, so you must know that dy by dx is equal to chain rule dy by dt multiplied by dt by dx. So let's do it part by part. Here, if you want to get dy by dt, it will be equal to, you need to differentiate, it will be 3t squared minus 1. This is for the first one. And then if you want to get the d, you have dx by dt here because a is the subject, x is the subject, so it will be 2t only. So you have now the derivative of dx by dt and dy by dt. How do you get dy by dx? In this case, it will be 3t squared minus 1. And if you want to get, instead of dx by dt, you get dt by dx, you just take the reciprocal of this. So the 2t will be in the denominator. So now you have the derivative. We got using the chain rule here. So we got this one. You have the value of t, which is 2. Just replace t by 2. It will be 3 by 2 squared minus 1 all over 2 by 2. It gives, this is 4, 3 by 4, which is 12. So it's 11 out of 4. This is the gradient. This is the value of the gradient for the tangent. So M1 is equal to 11 over 4. So M2, the gradient for the normal, is equal to negative 4 over 11, negative reciprocal. So now you have the gradient for the normal, and we need to find the equation for the normal. You need to have a point or the y-intercept. So to get a point, you have the value of t, where the normal meets C1. So here you need to replace t in x and replace t in y to get the point. So to get the value of x, replace t by 2. So it will be 2 squared minus 1, that gives 3. And the y is 2 cubed minus 2. It gives, this is 8 minus 2, which is 6. So the point now is 3 and 6, where the normal meets the curve at this point. So this point is 3 and 6 here. So now we have a point and we have the gradient. So let's work on the equation. The equation will be y minus y1 is equal to m by x minus x1. So you can now replace y minus 6 is equal to negative 4 over 11 multiplied by x minus x1, which is 3. So you need to expand in here. Make the 11 on this side, multiply by this side, and negative 4 by this side. So you're going to have 11y minus 66 is equal to negative 4x plus 12. Make them all on one side to get this form. So it would be 4x plus 11y. And then we have minus 66, and you will add 12. It will be shifted to the other side with a different sign. So it will be negative 78, and this is equal to 0. And here is the required equation for the normal. So now we got the equation for the normal as it's required, and we got the full 5 marks. So let's work on point B, and you need to pay attention very well to this part. In point B, we need to get, so let's clear the board first. So in point B, it says the curve C2 has parametric equations. X is equal to 12.5 plus a cosine t, y equals 15 plus a sine t, where t is between 0 till 2 pi, where a is a constant. Find the range of values of a for which the curve C2 does not cross or touch the line L. So now C2, a new curve, for example, is drawn like this, and here is the line L, so they do not cross each other, and you have the parametric equation. So now we have the equation of line L. Line L is the normal. Line L is the normal of C1. So whenever these two, they do not touch or cross each other, so what you do, you have 2 ways. We can work on the easier. Since we have the equation for line L and we have the parametric equation for C2, so you can replace each x here and each y here. So you will have 4. Instead of x, you're going to replace the given value, which is 12.5 plus a cosine t, and then plus 11 multiplied by y, which is 15 plus a sine t, here the value of y, and then minus 78 is equal to 0 in this case. So you need to replace or expand in here, expand, so this will be 50 plus 4a cosine t added to 11 by 15 is 165 plus 11a sine t, and then minus 78, or you can just make the 78 on the other side after the equal sign. So as you know, we need to work on identities that will help you, or you can just collect the constants first or the absolute values and leave them on the other side. So you're going to have 4a cosine t, and here you have 11a sine t is equal to 165, and plus 50 gives 215. If you shift it to the other side, it will be negative 137. If you make 78 minus 215, it gives negative 137. So if I square this one, and this one, and this one, and this, so why shall I square them? Because I'm going to work on the identity sine squared t added to cosine squared t, it gives 1. So whenever you are working with parametric equations and you have trigonometric ratios, you will try to relate them by any of the identities you have studied in pure math 3 or pure math 2, the trigonometric identities you have studied before. So what I will do now is, as I said, I'm going to square this, this, and this. So it will be 4a cosine t all squared added to 11a sine t all squared, and here we have minus 137 all squared. So let's continue there on this side. We're working on this identity, so now it will be, this value will be 16a squared, 16a squared cosine squared t added to 121a squared, and here we have sine square t. It gives the square of 137, or you can just keep it as 137 squared for now, because as you know, the square removes the negative sign, and this is the part here. So now the cosine squared t, sine squared t, it gives 1, so you have 16a squared plus 121a squared is equal to 137 squared, and this gives 137a squared is equal to 137 squared. So you can divide by 137 by 137, so you remove one of these. So now a squared is equal to 137. So you can take square root for both. So a is equal to, but now whenever you're asked to find range, so it will be negative root 137 and positive root 137. So a is between the square root, positive square root of 137 and negative square root of 137, and this is the final answer. As I said at the beginning of the video, you can work on this way. Another way, you can make the cosine t as subject, sine t as subject, and then you use the identity sine square t plus cosine square t is equal to 1, and you do it. But after that, you will try to make all in one, in terms of one variable, all in x, in terms of x. Okay, and then you can replace it and you will get a quadratic equation. So you can use the discriminant a squared b squared minus 4ac less than 0, and you can do it. But this is a shorter way and easier way to solve this part. We wish